Okay, so welcome to the 1 Million Journey video series. So we're going to continue on now with sampling techniques, basically by example. I'm going to try to show you these three most common ones, at least in the educational system maybe that you are talking about. And they typically are involved when you are learning about statistics in one way or another. And these particular sampling techniques are simple sampling, stratified sampling, systematic sampling. Now, the word random very often is sometimes just dropped, but they are all random. So I'm going to show you by example what these three techniques actually are so that you can understand them a little bit better. Now, in statistics, or whenever you're asking some kind of a hypothesis, so you have a question that you want to be able to get data for, you're going to have to either, in some form or another, by experiment, some observations, surveys, or census, get data from the entire population, so from everybody interested, which is not always very easy to do. Actually, it's extremely difficult to do. So what people do, or what researchers will do, is they will sample, and they're going to use these three sets of sampling to reduce so that they can't go off after the entire population. They're going to take a sample of that population and then draw conclusions from that. So how do you do that, and what are these things? Let's imagine, now of course I don't know what you're going to be working on, but let's imagine that you wanted to find out whatever the question that you've asked, whatever hypothesis that you have set up for an entire high school population, and it's your school, so the entire one. I have no idea how many students you have within your high school, or maybe within your college, or even university, which is crazy big. But I will just throw a number out there. So the high school that I went to had about 2,500 students at the time. I don't know how much it has now, but let's assume that that's what we have. So our entire population is basically 2,500 students. For me to be able to get every student's results based on whatever hypothesis I'm having would be really hard, and it would take a very long time to do that. So what I'm going to do is I'm going to use these three particular techniques. So the first one, let's say simple sampling. Now you as the researcher will decide how many students you're going to have within your sample. This is something that you decide, maybe if it's a project or an assignment, maybe your teachers will tell you how much or how big your sample has to be. Let's assume, for my sake, that my sample is going to be 30 students from this 2,500. So I have 30 students that I will pick. Now, for simple sampling, what that actually means is that I have to pick 30 students from the entire 2,500 students in total. And I want to do it at random. So one way to do it is basically take all the students' names, put them in a hat. So you have some hat. All of these names are inside. And you start drawing at random, first student, second student, third student, fourth student, and so on until you get to 30. Now, drawing out of a hat and putting all of those names in, researchers won't really do that anymore. So how do you actually create these at random? So nowadays, we actually have software that randomly can provide you 30, for example, samples if you need 30, or 100 if you need 100. But you're still going to have to do work. So one way to do that is every student will have either a student number, And with that student number, you can assign, the first student with the lowest student number as number 1. Then student number 2, student number 3, student number 4, and you list them from 1 to 2,500. And now you're going to pick them at random. So here I'm going to show you, because on the internet, there's now quite a few tools. One of the tools, which is a nice tool, is random.org, which is a free tool, where if you had the list of students listed from 1 to 2,500, you can generate, I'm going to zoom in here, you can generate 30 random samples. So notice here, part 1, it says, generate. Now I don't want to generate 100. I have 30 students that I want to generate. Now, the maximum, that we can, at least in this particular software, that we can generate is 10,000. I'm only looking for 30. You can find other applications on the internet if you like. And if you're a true researcher, there are other tools as well. Now, each integer should have a value between. So now, because I've listed my students from 1 to 2,000, so 2,500, which is the total number of students, now it asks me for the format how I want it. I don't really care how those numbers are allocated. So let's keep them at 5 columns. And now all I have to do is I'm going to hit get numbers. So now it is generating for me the 30 students, and these were the numbers that it has generated at random. So notice, first student that I would have asked, whatever question I was asking, was the 1,244th student. And then the second was 1650, and so on. So these were just randomly generated between 1 all the way to 2,500. That would have been simple sampling. All I'm doing is I'm taking the entire population, and at random, I'm going to pick 30 students out. That's how you can actually do it. So coming back here, that's simple sampling. Hopefully that gives you a sense of what we have. Now let's stick with that population of 2,500. I can change the sample size for the other ones, for instance. What is now stratified sampling? So my second idea in terms of sampling techniques might be called stratified. Stratified means that you are grouping. You have some groups that you've created where you're going to be taking your samples from. So now let's still imagine that I have a population of 2,500 students. Now, what are the possible groups in, let's say, a high school or college or something else, or elementary school? Well, the possible groups, the stratified, the stratas, as they might be called, so these are stratas, so the groups that I might have, is maybe by grades. Say if it's high school, it's grade 9, grade 10, grade 11, grade 12. I don't know how many grades your high school has. So those could be the stratas. Grade 9, grade 10, grade 11, grade 12. What are other possible stratas? Maybe your high school is, for example, has a certain number of classes. You don't have just grades, you have certain classes, right? Or cohorts, sometimes they're called, where you're stuck with a certain amount of students, okay, for your cohort. For example, grade 9 might have 3 or 4 cohorts, where those students are going to the same classes at different times or whatever it may be. So that could be a strata. All right? Or it could be just regular classes in general, except in that case, there's going to be a lot of classes that you have. Let's say first period in high school, so your 8 a.m. class or whatever time you start, what class do you go to? That could be your strata, that group. And then, of course, there are many other stratas that you can have. Let's keep it simple for this example. I'm going to say that my stratas would be, for instance, grade 9, grade 10, grade 11, grade 12. Now, if I'm still, okay, so in this case, if my sample is 30 that I have, I want to be able to pick, okay, at random from these particular strata so that I have a total of 30 or a size of 30 sample. Now notice that this is 4 groups. So a researcher would probably say a sample of 30, because it doesn't really evenly go into it, right? It's not like I can take a certain amount of students. So I'm going to change the sample size, for instance. And let's say I'll make the sample size, in this case, because I'm taking 4 groups, my sample size is 32. So something which is divisible by 4. So 32 divisible by 4 is basically 8. So what I have to do now is in my sampling, I'm going to take 8 students from here, 8 students from here, 8 students from here, and 8 students from here. Notice that will equal to my sample size of 32. So if these are my stratas, I'm going to pick 8, 8, 8, 8 from each. Now, how do I pick these 8 students? Do I just take them as I like? The answer is no. You basically will do exactly the same thing as you did in simple sampling. Meaning, from each group, so from grade 9, again, you're going to have a list of grade 9 students. And in that case, you're going to use simple sampling for that strata, that group, to pick out 8 students. So I don't know how many students there are in grade 9. However, I'm going to take a guess here, and you can go back. So I'm going to go back to this random generator. Let's assume that grade 9, so grade 9 had 787 students. And again, I would list them 1, 2, 3, 4, and so on. And so I want to generate 8 students from a list. So let me go back here, 787. So from 1 to 787. How many columns? Again, I don't care. Let's get the numbers. Notice all it generates is 8 student numbers. 1, 2, 3, 4, 5, 6, 7, 8. And that for my strata, my grade 9, I would pick these students out. That's at random. Again, or I can draw them from a hat if I like. And you would repeat that for grade 10, for grade 11, for grade 12, so that you have a sample size of 32. That should help you in understanding what this stratified sampling is. It's not easy because it depends, again, what your hypothesis is, what your question, what you're asking about, and then how big your population is, and then how easily you can stratify it. So researchers will use the technique best suited for their application. Simple sampling, easy to understand. I hope now stratified sampling is also easier for you to understand by seeing this particular example. Now, the last one is systematic random sampling. This particular sampling technique is not a hard one. So in systematic sampling, so let's say if we have that 2,500 students, so you take your entire sample size. The first thing that you do in systematic sampling is that you will, at random, select a starting point. Now, what do I mean by a starting point? So you have a list of 2,500 students. So this list continues on. However, they are aligned. Each student, again, maybe by student number, and then they're just continuously going down, maybe alphabetically or something like that. So you have this list, 2,500. You want to first, at random, find a starting point. Meaning that you're going to pick some student out of this entire list. Okay, you're going to pluck them out at random. So now, drawing it out of a hat, or again, so I'm going to go here. Now, what you see on the screen is I put random number generator. So instead of creating a list of students now like we did with simple sampling, for example, now I just need one number. So I just put here, I'm going to use random number generator. This is provided directly in Google, or you can use anything else. Now I have, so my maximum number of students is 2,500. So I'm going to pick just one at random. Oh, so it turns out 2,408. So I'm going to pick that student. So it's actually way down the list, somewhere here, 2,408. That is my start. So that's going to be my first sample. Now, from here, I will pick the kth student until I reach my maximum quota of 30. And how do I do that? Okay, so how do I generate my K, right? So how do I pick it? Do I just randomly do K? No. What you do is you take your total number in your population, in your list, and then you divide by the sample size that you want to have. Because this way you will systematically, keep picking students, now whatever value this may be. All right, so here, let me take out the calculator. I have 2,500 divided by 30, 83. Now you get 83.333. Well, you can't take a third of a student, so you can round this. So we're going to round it down, so we have 83. Now, as a researcher, you pick your sample sizes, and sometimes depending on the population, you might take one more sample or two more samples or whatever, so that maybe you don't have these decimal places in there. I don't really care. I just said 30 honestly at random when I was talking about this video. So what does this 83 or what does this K represent? It means that now what I will do is, since my starting point is 2,408, my next student is going to be, so I'm going to add now 83 to this. So I have 2,408 plus 83. My next student is going to be 2,491. So now I have two samples. Now you notice, obviously, because if I say plus 83, I get 2,574. I don't have that many students. So what do you think happens? What happens is that you're going to circle back. So you're going to go back to the start of the list, and basically, so the next one might be the 74th student. And then again, you're going to keep adding 83 until you collect your 30 samples. And then you're basically going to go in an entire loop picking your samples. That is systematically picking your samples at random. Now, the random was because you chose at random your starting point. That's what systematic sampling is. So this gives you a sense through an example of understanding these three. I know that there are more sampling techniques. If you're running into one and hasn't been listed here, these are kind of the most common ones. You can research them if you like. I hope you found this useful, and these examples show you that really, statistics isn't that difficult once you grasp the concepts, in particular in the sampling space. Thanks for watching, everybody. We'll see you in a future video.